Hello dear students, this is a power problem. Okay, the circuit shown below, we have bunch of resistances from R1 to R8 resistors, and first we label all the resistances R1, R2, R3, R4, R5, R6, and then R7 and R8. So we have one bunch of resistances from R1 to R8, and the resistance value of the each resistance is given, and we need to find the EMF of the cell, the maximum voltage that the cell can provide, so that any power of over 2 watt, so that the power dissipation maximum power should be 2 watt. Any resistance will dissipate maximum power 2 watt, so that the resistor will not fail. Okay, resistor will not fail, and we have to find the maximum voltage of the battery. So we have to find the what is the voltage that we need to set, so that the resistor can only dissipate 2 watt of power. Okay, so in this problem we have to solve step one is to solve for the first we find the equivalent resistance. In order to solve this one, step 1 is find equivalent resistance or total resistance of the circuit. We first find, in order to find the potential maximum voltage, we need to find the first equivalent resistance. Okay, so equivalent resistance is simply, first we solve for R1 and R2, because R1 and R2 are parallel. We solve them parallel combination, and R5 and R6 are also parallel. We also solve them, and then R4, this one, these three are also parallel. We first solve all the parallel combination, and then we solve for the series combination. So R1 and R2. So RA is equal to R1 parallel to R2. So R1 R2 are parallel. So if two resistors are parallel, so that the simplest formula is multiply their resistances and add their resistances to find the equivalent resistance. So R1 and R2 are the 2 ohm, so we have to find 2 multiply 2 divided by 2 plus 2. So 4 over 4, that the resistance RA between R1 and R2 is 1 ohm. Okay, now similar fashion we find resistance between R5 and R6. Suppose this is RB, that is R5 and parallel to R6. So R5 and R6, R5 is 20, R6 is also 20, 20 into 20 over 20 plus 20, so that the parallel total resistance between R5 parallel R6 is equal to, that is equal to 10 ohm. When we solve, we get 10 ohm. Okay, so we replace these two resistors with the RA and these two resistors with the RB, so that the modified circuit of this is mentioned as modified circuits. Let me draw the modified circuit. So for example, here we have EMF, positive negative EMF battery, then we have RA, that is equal to 1 ohm, then R3 is 2 ohm, and then we have R4 10 ohm, then we have RB, because R5 and R6 are parallel, so RB is equal to again 10 ohm. With these are parallel with the 15 and 20, R7 and R8. R7 15 ohm and parallel with the R8, that is equal to 20 ohm, and then we complete the circle. Okay, now now we solve this, because you know that these three are in again the parallel. These three are in parallel combination. So 10 plus 20, 10 plus 10 are the these two in series, and these 20 ohm and 20 ohm is parallel with the 15 and 20 ohm. So So the equivalent resistance now, total resistance is equal to, now we solve for total equivalent resistance is equal to RA plus R3 plus R4 plus RB, because you know the R4 and RB are series, R4 plus RB are in series, and they are parallel with the R7, and R7 is parallel with the R8. R7 is parallel with the R8. Okay, now we solve first one by one. R equivalent is equal to RA. RA is 1 ohm, R3 is 2 ohm plus R5 and RB. R5 is 10 ohm, RB is again 10 ohm, that is parallel with the 15 ohm, and that is parallel with the 20 ohm. Okay, now we solve R equivalent equal to now we solve 1 plus 2 is equal to 3 plus 10 plus 10 20, that is parallel with the 15, that is parallel with the 20. Okay, so for simplicity we solve first 20 20. R equivalent is equal to 3 plus 20 parallel with the 20 parallel with the 15. So R equivalent is equal to 3 plus 20 parallel with the 20. So 20 multiply 20 over 20 plus 20, that parallel with the 15. Okay, R equivalent equal to 3 plus, now we solve for this, that gives us 10 parallel with the 15. So 3 plus 10 parallel with the 15. So 10 parallel with the 15. So 10 multiplied by 15 over 10 plus 15. So 3 plus 6, which is equal to 9 ohm. So the equivalent resistance is 9 ohm. Step 1 is equivalent resistance is 9 ohm. Step 1, total resistance. First we find the equivalent resistance. Now second step, step number 2. For the step 2, we find the current through each resistors, because for the we don't know the current. So if we know the current, then we can apply the power formula. So that we need first find the current through each resistor. Current. Second step 2, current through each resistor. Okay, so we know that the total current that flows through the battery is I. Suppose this is I current. So at this junction, so the current is split into this one. So this is R8, R1, R2, R3, R4, R5, R6, R7 and R8. Okay, now I use different color for the currents. Okay, so this is current I8 that flows through R8, the current that flows through R7, that is I7, the current flows through the I6, that is I6, the current flows through the I5, that is I5, and similar way this is I3, this is I2, and this is I1. Okay, I1. So there are 8 currents that flow through the circuit. 8 currents that flow through the circuit. Okay, so first we simply, you can see that I and I3 are same. Total current I that meet at this junction, at this point, will be same as I3. So I3 and I are same. First I3 is equal to I. First problem is solved. Now you know that if I3 and I are equal, they split into two parts, because 22 ohm is the same resistors. So they split into two parts, equal parts, mean current is half current goes through the 2 ohm, half current goes through the 2 ohm, second one R2. So it means I1 and I2 equal to I3 over 2. I3 over 2 half, mean half, or you can say that 0.5. I3 is equal to I1. So I1 and I2 is equal to half current. Half current goes through both. So I1, I2, I3, three currents have been solved. Now we solve for I7, 8 and 4, 5. Okay, now we solve for the 7, 8, 4, 5. In order to solve the current through R7, we use the formula. First we solve Okay, first we solve for I7. So in order to solve for I7, we know that the I7 is equal to, we use current divider formula. Current divider formula. So what is current divider formula? Current divider, according to current divider formula, the current through any resistors is equal to the opposite equivalent resistance divided by the sum of total resistances multiplied by the source current, total current. So total current is I. First we write the formula, current divider formula. Current through any resistor, mean current through R7 is equal to opposite resistance divided by total resistance in parallel and multiplied by the total source current, okay. So I7 is equal to so opposite resistance. So I7 R7 is the opposite resistance between R7 is actually R7 is 10 ohm. You know that the R7 is 15 ohm. So the opposite resistances are 20 and 20. So I made a simple circuit here. For example, this is 15 ohm and opposite total resistance is 20 and then 20. First we solve for 20 ohm, total of 20 ohm and the 20 ohm. So the total of 20 and 20 ohm is 20 parallel with the 20. So that is equal to 10 ohm. 20 parallel 20, so 10 ohm. So 15 ohm and the parallel resistance is 10 ohm. So 15 and parallel resistance is 10 ohm. So opposite total resistance is 10 ohm divided by sum of resistance. Sum of resistance is 15 plus 10, that is 25 ohm. The total parallel resistance is equal to 10 plus 15, and the source current is I, total current. So 10 over 25, that gives us 0.4 I. So I7 is also solved, that is 0.4 I. So I7 is 0.4 I. So similarly we solve for other currents. So we solve KCL, Kirchhoff first rule, Kirchhoff current rule. Okay, so in order to solve the Kirchhoff current rule, we know that the I is separated into three parts, I8, I7 and then I4, I4 or 4, 5, 6 or something. Okay, so that the total current is I4. So total I current is equal to I4 plus I8 plus I7. I4, this is I4 current, I4 plus I7 and then I8. So I is split into two parts, I4, 7, 8. But we need to find the current I4 plus I8. So I4 plus I8 equal to I minus I7. So I4 plus I8 equal to I minus I7. So I7 is actually, we know that we have found I7, 0.4 I. So we solve, we get 0.6 I. So I4 plus I8. As we know that I4 and I8 are in parallel and they have the same resistance. I4 plus I8 is 0.6. So I4 and I4 is equal to I8 is equal to 0.6 divided by 2. 0.6 divided by 2. Half of current goes through I4, half current goes through I8. So 0.3 I. So finally we have also solved I4 and I8. Now we know the I5 and I6 is divided into two parts. I5 plus I6 is equal to, you know that I5 and I6 is equal to I4, because half of current is flowing through I5, half of current flowing through I6. They combine at this junction. I5 and I6 combine to make I4. I5 and I6 makes to combine I4. So I5 plus I6 is equal to I4. So I4 is actually 0.3 I. We already solved 0.3 I here. So I5 plus I6 is equal to 0. So as we know that I5 and I6 has the same resistance, so half of the current goes through I5, half the current goes through I6. So I5 is equal to I6 is equal to 0.15 I. So second step we solve for all resistances, all currents. Now third step, we solve for the power. Step 3, find power and check maximum power. Which resistors has maximum power? Okay, so we solve for the power. So we solve for one by one. So power through I1 P1 is equal to I1 R1 I1 square R1. So I1 is 0.5 I square into R1. R1 is 2 ohm. That is equal to 0.5 I square. So similarly P2 is equal to, I use direct equation. I2 is given, I2 we find I2 is 0.5 I square into R resistance R2 is 2 ohm. That is equal to 0.5 again 0.5 I square. Similarly P3, so P3 is equal to I3 square. I3 is actually I3 is 2. I3 is, I think I3 we have checked I3. So I3 is I3 is I, simply I3 is equal to I3 is equal to simple I square into I3 square into R, resistance of R3. So the resistance R3 is 2, so it is 2I square, because I know that I3 is equal to I. So similarly P4, for P4 I4 square, so I4 is 0.3 I square into resistance R is 10 ohm, that is equal to 0.9 I square. Similarly P5, so the current is 0.15 P5 0.15 I3 square I square sorry into resistance is 20 ohm, that gives us 0.45 I square. Similarly P6 is equal to 0.15 I square, and the resistance R6 is 20 ohm, that is equal to 0.45 I square. Similarly P7, so P7 is I7 is 0.4 I square multiplied by R is 15 ohm. So I'm using directly equation because I write current that we already found and multiply by the resistance. Okay, so 2.4 I square. So P8 is equal to I8, that is equal to 0.3 I square into resistance is 20 ohm, so that gives us 1.5 I square. So if we compare all the powers, so we come to know that the power dissipated by P7 is greatest, because the current is, you know that this is 2.4, P7 is the greatest value. P7 has maximum or greater power loss or dissipation. Okay, so if P7 has greater power loss, so it means the current flowing through that resistor is the total current that can flow, that the maximum current can flow. So that the P7 is equal to P maximum, we know that the P7 is equal to, gives us the maximum power, sorry, P7 is equal to P max, and P max is, we know that P7 is 2.4 I square, that is equal to, maximum power is in the given in the question, that is 2 watt. With maximum power, that any resistor can have maximum power of 2 watt. So I square is equal to 2 over 2.4, and I is equal to under root of 2 over 2.4, that gives us 0.91 91287 ampere. So the current that maximum can flow through P7 is 0.9. If the current is greater than this value, the power the resistor will fail. Okay, so that the battery can be, so we use Ohm's law, simple Ohm's law. According to Ohm's law, V is equal to IR, EMF is equal to IR. So we need to find the EMF. So EMF is, current is 0.91287 ampere multiply with the resistor. So that R7 resistor is actually, you know, the R7 R equivalent resistance, because the total resistance is 9 ohm, 9 ohm, and the maximum current can flow through the this R7 is 0.9. okay, so the EMF will be equal to, we multiply both, we get 8.21 2158 volts. So our answer can be 8.22, or our answer, if we have more significant figures, so if we can also write 8.21 from Isaac Physics. Okay, you can check your answer. 8.22 volt is the correct answer. 8.22 volts, 8.22 volts is the correct answer. So let me check this answer. Yeah, this one is the 8.22 is the correct answer in volts. Okay, this is a power problem. Okay, thank you.